Hello everyone. Welcome to another video in the Edge AI Masterclass. In this video, we will explore briefly some of the most popular classical machine learning algorithms, as well as understand their applications in real-world scenarios. So let's begin. Let's start with linear regression. This is a type of regression technique used to predict a continuous value by finding a line that best fits the data points. An application of linear regression could be predicting the price of a house based on its size and location, like we discussed in the previous video. Linear regression is widely used due to its simplicity and efficiency in predictive modeling. Next, we have logistic regression. Unlike linear regression, logistic regression is used for classification tasks, not regression. It predicts categorical outcomes, like whether an email is spam or not, or whether a patient's tumor is cancerous or not, and so on. It does this by calculating the output values between 0 and 1 using a logistic function or an S-shaped curve, which can then be taken as probabilities. Moving on, let's explore support vector machines, or SVMs. This algorithm can be used both for classification and regression, but is primarily used for classification. The goal of an SVM is to find the best boundary that separates the different classes of data. For instance, it can classify whether a customer will buy a product or not based on previous purchase data, or whether the battery of an edge device will die out before a task is completed. Naive Bayes, based on the Bayes theorem, is another classifier. It's particularly useful when dealing with large data sets and can efficiently make predictions despite its simplicity. An example is classifying a text into different categories based on the frequency and type of words. Random forest algorithm is an ensemble or collection of decision trees and is used for both regression and classification. Decision trees, as the name suggests, is a tree of decisions generated by making decisions one after the other in a hierarchical setting. For example, for a loan application system, a decision tree could first check the credit score. If the credit score was less than 550, the application could be rejected. If higher, the person's salary and monthly savings could be checked. If the saving was more than the monthly loan installment amount, the loan could be approved. If not, the application could again be rejected, and so on. Coming back, random forest works by building multiple random trees and then combining their outputs together to get a more accurate and stable prediction. As we mentioned in a previous video, decision tree-based algorithms' predictions are very easy to explain. This makes them the preferred algorithm for domains like healthcare and banking finance. For example, they can be used to predict whether a credit card transaction is fraudulent or whether a loan application should be approved or not, like we just saw. Lastly, let's delve into clustering with k-means. K-means clustering finds groups or clusters in the data by partitioning n observations or data points into k clusters where each observation belongs to the cluster with the nearest mean. A practical application of this could be segmenting customers into distinct groups based on shopping patterns. And that was a quick overview of some foundational machine learning algorithms. Each of these can be implemented on edge devices, streamlining processes and enhancing decision-making right where data is generated. In the next few videos, we will explore these algorithms in a bit more detail. See you there.